Today we're going to talk about solving exponential equations. And so I'm going to start off by giving you some steps. So step 1, you're going to isolate the exponential term. Step 2, you're going to switch to logarithmic form or take the natural log of each side. And as we go through, I'll discuss which one of those we want to actually use. Step 3 is use logarithmic properties. And step 4 is solve for the variable. So now let's do some examples. So example 1, if we have 4 to the x equals 15, this 4 to the x right here is our exponential term. And it said step 1 was to isolate the exponential term. Well, that exponential term is already isolated, so that's done for us. And then it says to switch to logarithmic form or take the natural log of each side. And so if your calculator is able to do the log-based function or operation, then you're going to want to convert it to logarithmic form. If your calculator does not do the log-based function, then you are going to want to take the natural log of each side. So I'm going to do converting to logarithmic form first. So if we convert this to logarithmic form, it's going to be log base 4 of 15 equals x. And then you're going to take that and you're going to put this in your calculator. And when you put this into your calculator, you get that x is equal to approximately 1.953. And this is your final answer. So now, if we want to do this taking the natural logarithm of each side, I'm going to start by rewriting my equation. And so the exponential term, as we know, is already solved for. So from here, I'm going to take the natural log of each side. And so that gives me the natural log of 4 to the x equals the natural log of 15. And so now I'm going to use my exponential properties. And so I'm going to take this x, and when we have an exponent here, according to our properties that we've learned, you can move it to the front of your logarithm. So that gives us now x times the natural log of 4 equals the natural log of 15. And now we need to solve for x, so we're going to do that by dividing each side by the natural log of 4. And you're going to find that x is equal to the natural log of 15 over the natural log of 4, and when you put that into your calculator, you will get 1.953 again. Example 2. So if we have 40 e to the 0.6x equals 240. So this right here is your exponential term. And so you're going to want to isolate that, and to isolate it, we're going to divide each side by 40. And when we do that, we get e to the 0.6x equals 6. And now I'm going to convert this into logarithmic form. Since we have a base of e right here, we're going to use a natural log because that has a base of e. So it's going to become the natural log of 6 equals our exponent. And then we need to solve for the variable, so we're going to divide each side by 0.6. And so we're going to get that x is equal to the natural log of 6 divided by 0.6. And when you do that in your calculator, you're going to get 2.986 as your final answer. And now if we were to solve this by taking the natural log of each side, we're going to start right here after we've already isolated our exponential term. So e to the 0.6x equals 6. And then I'm going to take the natural log of each side. And so I get the natural log of e to the 0.6x equals the natural log of 6. Using our logarithmic properties, we're going to take this exponent and move it to the front of our logarithm. So we get 0.6x times the natural log of e equals the natural log of 6. Our properties tell us that the natural log of e is equal to 1. And so we just end up with 0.6x equals the natural log of 6. Solve for x by dividing each side by 0.6. And if you notice, right now we're at the same steps as we were on the left, and so we're going to get the same answer of x equals 2.986. Example 3. If we have 5 to the 4x minus 7 minus 3 equals 10. So right here is our exponential term, and we need to isolate that. So to isolate that, we're going to add 3 to each side. So we get 5 to the 4x minus 7 equals 13. Now we're going to convert this into logarithmic form. So we're going to get log base 5 of 13 equals 4x minus 7. And now we solve for x. So we're going to add 7 to each side. So now we have log base 5 of 13 plus 7 equals 4x. And now divide each side by 4. And so you get that x is equal to log base 5 of 13 plus 7 divided by 4. And when you put that into your calculator, you're going to get 2.148. And so this would be your final answer. Now let's solve this taking the natural log of each side. So we're going to start from where we isolated our exponential term. So we have 5 to the 4x minus 7 equals 13. Now I'm going to take the natural log of each side. So now I have the natural log of 5 to the 4x minus 7 equals the natural log of 13. And now using exponent properties, I'm going to take this logarithmic properties, I'm going to take the exponent and move it to the front of our logarithm. So now we get 4x minus 7 times the natural log of 5 equals the natural log of 13. Now I want to get, that should be a 13, that did not write well. Now I want to get the x by itself, so to do that I'm going to divide each side by the natural log of 5, which gives me 4x minus 7 equals the natural log of 13 over the natural log of 5. Now continue to solve for x, so we're going to add 7 to each side. And so we get 4x equals the natural log of 13 over the natural log of 5 plus 7. And now I'm going to divide each side by 4. And so you get x is equal to the natural log of 13 over the natural log of 5 plus 7, and then all of this divided by 4. And when you type that into your calculator, you'll get the same answer as before of 2.148. And now the last example, example 4. If I have 3 to the 2x minus 3 equals 7 to the 3x plus 2. So now notice this looks a little bit different because we have an exponential term on each side of our equation. And so that means that you have to take the natural log of each side here. And so the natural log of each side, so you have the natural log of 3 to the 2x minus 3 equals the natural log of 7 to the 3x plus 2. Using our logarithmic properties, we're going to move each of our exponents to the front. So we have 2x minus 3 times the natural log of 3 equals 3x plus 2 times the natural log of 7. And so remember that the natural log of 3 and the natural log of 7 are just numbers. So from here, we're going to take the natural log of 3 and we're going to use distributive property and multiply it through that set of parentheses. And we're going to take the natural log of 7 and use distributive property to multiply through this set of parentheses. So when we do that, we get 2x times the natural log of 3 minus 3 times the natural log of 3 equals 3x times the natural log of 7 plus 2 times the natural log of 7. So from here, we need to get everything with an x on the same side, and we need to get everything without an x on the same side. So to do that, I am going to subtract 3x natural log of 7, and then I'm going to add the 3 natural log of 3. I'll do that in a different color. And so when we do that, we end up getting 2x times the natural log of 3 minus 3x times the natural log of 7 equals 2 natural log of 7 plus 3 natural log of 3. Now from here, if you notice, you have an x in each of these terms. So we can take those x's and we can factor them out. And so we end up with x times 2 natural log of 3 minus 3 natural log of 7 equals 2 natural log of 7 plus 3 natural log of 3. And so now from here, we need to continue to solve for this x over here. So to do that, we're going to divide away this 2 natural log of 3 minus 3 natural log of 7 on each side. And so you end up getting that x equals 2 natural log of 7 plus 3 natural log of 3 divided by 2 natural log of 3 minus 3 natural log of 7. If you were to type this into your calculator, make sure that you put parentheses around the numerator and around the denominator. And when you type that into your calculator, you find that x is equal to negative 1.974, and that is your final answer.